Hello, today we are reviewing radicals and radical operations. We're going to start out with our square roots, move into our cubed roots, talk about addition and then multiplication. So first, we want to find the simplest form of the square root of 108. So, what's the first thing we have to do? Exactly, we're going to break it down using our prime factorization. So I'm going to take the 108 and I'm going to do my ladder, upside down division. Now that I have my upside down division, I'm going to come back here and say, okay, my index on my square root of 108 is 2. So now I'm going to go ahead and I'm going to say every 2 to get out of my house being my radical. So I have one set of 2 that comes out. I have one set of 3 that comes out, but I have this guy who stays in because he has to have a partner because it's a square root with an index of 2 to get outside of that radical. So now I multiply what comes out and I leave what comes in. For B, he just looks funny. As a reminder, this right here is my index. My index is what goes inside my radical. It means it's going to be a square root. This, just as a reminder, would be an exponent. You do that in Algebra 2. So this guy here just gets rewritten as the square root of 175. Now we proceed just like we did on the first one. The first thing I'm going to do is now make my tree. Dividing by 5 because 5 is prime. Now that I've looked at my tree, I say, okay, I have a pair of 5s. They come out of my house. I have a 7 that's left in my house, so it's 5 root 7 as my final answer. Number C, letter C, is a little bit different because I have this guy here who's already outside of my house. He needs to come down and be part of my answer who I multiply. When I do that tree, he gets multiplied back with whoever comes out from that tree. So again, our tree, I'm going to start with 2. Goes 1, which is 1 left over, goes 8, 180. Divide by 2. Divide by 5. And right here, I could have divided by 3. I just spotted the 5 quickly. So I said, hey, because I spotted him quickly, I'm going to go ahead and do him first. So now this guy's got a little more coming out of my house. I have a pair of 2s here. He's going to come out. I've got a pair of 3s here. He's going to come out. So all of that comes out. These guys stay in. Again, whoever stays in gets multiplied back together as well. So now I have 2 times 2, which is 4 times 3, which makes 12. 2 times 5 makes 10. So 12 root 10 is my simplest form of my radical. So is my cubed root any different from this process? No. My cubed root here, I'm still going to do my factor tree, except for now my index here says I've got a 3. This means I've got to pull 3 out to make 1 outside of the house. That's all that changes. So I start with 40. Still same process. Do my factor tree. If you need to pause because I did the factor tree too fast, just pause the video and then finish your factor tree. Now I have a group of 3, because remember, it takes 3 to make the number on the outside. So I have 2 came out. Do not forget the little 3, so we know he's a cubed root, and 5 stays in my radical. He's got a little bit more going on. Remember, this means cubed root, so all it is a fancy way to say negative 320. But he has a negative. So because he has that negative, I have to remember that that's really, whenever I see the negative, it means -1 times -1 times -1, which means this guy comes outside to be -1. Because I have 3 -1s make a negative, because 2 negatives make a positive. So with that, now I can break down my 320. A lot of breakdown there. Again, if you need to pause the video because you're not finished breaking it down, pause the video. So now I need to come back and say, okay, I have one group of 2, so he's going to hang out with my -1. I have another group of 2, he's going to hang out with my -1, and I have a 5 left over. I'm going to simplify -4 cubed root of 5. Now I'm looking at C. Again, whoa, 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 I got this little negative guy going on. Automatically, he's going to come outside the house as like a -1. With him coming out of the house like a -1, that makes -2 times a -1 cubed root of 16. So right away, I've got 2 cubed root of 16 because negative and negative makes a positive. So now I need to break down my 16. One set of 3s and a 2 left over, so it's 2 times 2, one set of 2s, sorry. So it becomes 4 cubed root of 2. Okay, now we're going to look at some operational stuff. Here, you have to remember that a radical is just a fancy thing, like a label. It's the same thing, remember, when we talked about this as being like 3x plus 2x. We would just combine our like terms and get 5x. Same thing here. It's just a radical 5 and a radical 5. I'll add my coefficients, same kind of deal, keep my radical. Straightforward. But what happens when they're not the same? I can't do that. They're not like terms. Or are they? We need to come down and break them down to their simplest form. Again, not hard, just tedious. So I need to break this guy down first. Remember, he's on the outside. He will come down with him. All right, so now that I've broken them down, I have a 2 that was outside, I have a matching 3, and a 2 left in my house. So he's 6 root 2. I had a 3 that was outside, I have a matching 2, and I have a root 2 left inside. So he's 6 root 2. Now I can add my coefficients together, which are the 6 and the 6, to get 12, keep my radical root 2. Saying I've got 6 of them, I've got 6 more of them, I now have a total of 12 of them. But they have to be alike to go together. Otherwise, I can't put them together. It's like an x and a y. I can't put them together. All right, this guy's a little bit bigger. Not bad, just bigger. So I'm going to have to break him down. So we know there's 3 different things here. We know they don't match. I don't know if they match when I'm done. So now, if you need to simplify them, let's simplify them. So I'm going to start here with my 160. Remember, my 2 will go down. I'm breaking down my 160. Again, just a little tedious, but not hard. Y'all are super smart. You can do this. I'm just going to go and break all of these down so then I can just look at what I need to do after. So I'm just going to go and break them all down. So now I can just focus on doing that. Again, if you need to stop to break them down, stop the video to break them down. I can do them a little bit quicker because I've been doing them for a long time. So if you need to stop the video, do that. So now, I had my -2. I have a square root, so I have one set. I have two sets. And I have a 2 and a 5 left over. Yeah, I'm spelling it out. That's okay. You can spell it out or not. So now I've got -2 times 2. 2 is -4. -4 times 2 is -8. Square root of 10. I'm subtracting. See, I've got my 2 3's here. So that's going to be 3 root 10 because it's going to be 3. These guys are left inside, so it's 3 root 10. And then I have a set of 3's, and I've got, this is plus, I'm just going to put plus. Oh, that's a minus, sorry. Plus, I have a group of 3's, and I have a 2 and a 3 left inside, which is 3 root 6. So now when I'm putting them together, I need to go ahead and only put together who matches. So root 10 and root 3 matches, they can go together. So I have my, I'm just going to put it over here. So I have my root 10, but I have -8 minus 3, so it's 8, 9, 10, 11. So -11 root 10. This guy doesn't have a mate. It's the same thing as saying x plus y. I can't put them together, so he's just going to be plus 3 root 6. I can't add them together. That is my final answer. I cannot put it together any further. That is my final answer. I can only put together who matches, just like terms. All right, let's look at some multiplication. The problem with multiplication is sometimes our numbers get large quickly. That's the only problem. No big deal, we're super smart. So when we're talking about things under the radical that are being multiplied, that means I'm putting this together and I'm just going to multiply 7 times 21. They're both under the radical. They stay under the radical together. So I have root 147. I just multiplied them. But now here's the good news. When I go to break this guy down, 147, I know that 7's prime and I divided it. It makes it much easier to figure out who made up my prime components of 147. So now when I'm simplifying him, my 7 comes out, my root 3 stays in. So just like last time, if he's under a radical, he stays under a radical. If he's not, he's not. So my 2 stays outside, but I multiply the 20 times the 3 together. So now I have 2 root 60, and now I need to break them down. So I only break down the 60. If I want, I know he's prime. I could jump right here and do this. That's fine. Again, if you need to stop to do the prime factorization, do so. I have a group of 2's that come out. Inside, I have a 3 and a 5, so it's 4 root 15. Remember, you only break down what's inside, and what's outside has to come down for the duration. All right, C is a little more complex. Notice each one gets a little more complex. So again, my numbers go together on the outside. On the inside stays my radicals. So my new problem becomes 30 root 20. So now I can break down my 20. I have my group of 2. So that 30 has to get multiplied with that group of 2. 5 is left alone, 60 root 5. D is our favorite distributive property. This one has to get multiplied by him, and he has to get again multiplied by him. Outside stays together because they're both outside. Outside stays together. Can he break down? No. Can he go together? No. That is my final answer after I distribute and clean him up. He doesn't go together. He's done. He does not move forward. now we're looking at E. Again, we're going to distribute 2 root 20, because it's 2 times root 20, minus 2 times 2 root 12. 2 root 12 simplifies to be 4 root 12. So are we done like last time? No, unfortunately we're not. 20 breaks down and 12 breaks down, so we're back to the old breakdown ladder. Again, tedious, not hard. So my 20 breaks down, again, pause if you need to. My 20 breaks down to here's an extra 2. So I have 2 times 2 root 5, which is 4 root 5. Minus, I have another 2, so 4 times 2, root 3, because my 3 was left over, minus 8 root 3. Now I have a 5 and a 3. Did they combine? No, so we're okay. A lot of the distributives don't combine too well. So now we're looking at number 5. With number 5, it wants to know what I was before I simplified. Well, let's think about it for a second. When I was simplifying, I had to have a group of 2 to go outside to be 1. So that means that here, if I have 10 on the outside and he wants to go in, that means he had to be 2 on the inside. So that means I had to start with 3 times that 10 times the 10, because 2 of them made 1 on the outside. I just need to simplify them. So what? We got 30 times 10 gives us 300. So he was root 300 before he started. It's just understanding that to go back into the house, I've got to double him to come out of the house to become 1. I hope that this extra review was helpful. Have a great day.